Hey guys, welcome to this session by Intellipaat. So R is a programming language developed by statisticians for statisticians. So if you are interested in any sort of statistical analysis, then R should be your go-to language. And also R is a versatile language. It is a great visualization tool and it provides multiple libraries for machine learning algorithms. So in today's session, we are going to learn about R programming. Now before going ahead, do subscribe to Intellipaat's YouTube channel so that you never miss out on any of our upcoming videos. And also, if you are interested in doing an end-to-end certification course on data science with R, then Intellipaat provides just the right course for you. Now, let's go through the agenda for today's session. We'll start off with a quick introduction to R programming, and then we will learn about R Studio's GUI. We will also learn about different data structures in R. Data structures like vector, list, metrics, and data frames. Going ahead, we will work with some inbuilt functions in R. And also, you can put down all your queries in the comment box. We would love to help you. So now, without any further delay, let's get started.
So R is an open source language. It is available free of cost for anyone to learn and apply, right? And R is a language which is little different from the traditional software building languages like C, C++, or Java, right? It was meant specifically, for or customized for statisticians who would not like to do much of coding but spend more time on understanding data patterns, right? So most of the functions are pretty straightforward, easy to learn, and easy to remember as well, right? R is a language for data analysis and statistical analysis. R is a visualization tool. Before R, there's a language called S. So R is derived from this language. If you read about the history, right, you'll get to know. But that's not very important here. So in R, you can do the data visualization. You can. It's an open source, cross-platform compatible software. It's a Turing complete language. I'm not sure what this is. I'll go back and check what this means. Okay. So installing R. So if you want to install R, you can go to this link. Can I copy it? You can use this for installing R. So all you have to do is open this link and click on download R for whichever operating system you have, like Linux, Mac, or Windows. Can you give an example? Abdul is asking, can you give an example of model building? Okay, model building. So that is what we are going to learn in these sessions, right? So when I say model building, right, a quick example is how do you predict data? Say I want to predict the sales, and we're talking a lot about sales, right? So sales is dependent on what? Sales is dependent on your stock, as I said, right? The price, the quantity, and the quantity stock, right? So let's take only these two variables. So let's say we have sales. I'll give you a feel before we jump onto R. So all of you can just look at the link and search for this download for R for Windows, Mac, and Linux. This is what you're going to click and download your software. Okay. Yeah. So sales is say dependent on your stock. When I say stock available, the goods stock, right, and not the stock price. And then price of every product, right? Maybe discount, whatever you offer, and let me call it X1, X2, and X3 respectively. Okay, and sales is Y. Y is what you're gonna predict, right? So what is model building here? If I want to predict sales, I would like to multiply this with X1, right? Say 2 times X1 plus 2 times X2 plus 3 times X3 is my sales, right? This is what you have assumed, that given a stock of like 10 units and the price is like say $5 per unit, and the discount you offer is like 10%, your total sales will be 10 plus 2 into 10 is what? 20, right? 2 into 5 is 10, and 3 into 10 is 30. So your sales will be 20 plus 10 plus 30, that is 60. So given these values, these all values of the variables, x variables, your sales will be 60, right? Maybe it's in dollar or rupees or whatever, right? So what do we need to find here when we are building a model? When you want to predict something, what is missing here? We want to predict these coefficients, right? Because all of the things are available to us. We know x1, we know x2, we know x3, and we want to predict y. So the idea of model building is solving this equation This is just one example. So solving this equation to find out these parameters, and these parameters are represented by beta 1, beta 2, and beta 3. So if you're able to solve these equations and find out these values of beta, the prediction is very straightforward. It's just like replacing the variable. So this is the exercise of model building. What are the methods, what are the algorithms, what are the statistics processes you can apply in order to find the values of these beta 1, beta 2, beta 3. Okay, I'll take up the next question. Aditya is asking, is model building dependent on categorical data or business requirement? Of course, both. So any kind of data, categorical, numerical, anything, and also on the business requirement. So what your business wants? So that is the end goal, right? What is the vision? And based on that, you look at your categorical, numerical, whatever data it is, and then try to build the model. And building the model, I think I explained now.
Just a quick info, guys. If you are interested in doing an end-to-end certification course in data science with R, then Intellipaat provides just the right course for you. You can find the course link in the description box below. Now let's continue with the session.
Nishant is asking why only 30% for testing data. Train and test the split, which I talked about, right? 70-30 split. So that you can experiment with. The standard is 30%, but people also do 60-40 or 80-20, depending on how much data you have. If you have sufficient data, even 20% will do, because you want to keep aside some data for testing, and that should be a good amount of data so that the testing is so the test sample is sufficient to confidently validate the model. Okay, so moving on, once you're able to install R, the next one would be you have to install R Studio. So R is the programming language, and once you install R, you'll get an interface where you can work on. But it's not really user friendly, and that's why we recommend installing R Studio, which is an industry-wide and commonly used IDE, a front-end IDE, which can be used to work on R. So the prerequisite to R Studio is you have to have R installed in your system. Okay, so all of you have the R Studio link you have in the decks, and this is what you have to click on, R Studio desktop. So once you install R and R Studio, you'll have a screen something like this. Okay, and typically an R Studio screen will have 4 windows. So let us understand these 4 windows. So this layout is pretty common and famous in the analytics and space. So even if I'm working on Python, so there are IDEs which support R Studio kind of layout for Python, because this is what everybody is used to in analytics. Okay. So the first one, the top left, is where you write your code. This is where you write your code, and these are our files which we are going to go through when we start learning the syntax, right? So this is your space where you write your code, top left. So let's say you are executing a line of code, y arrow sequence 1 5 by equal to 0.5. Don't worry about what this means. This is typically we're trying to create a sequence of numbers with a 0.5 bin. So I execute this. So as soon as I execute this, the same code replicates here. How do I execute? Either I select this whole line and click on this run. We have a run here. Else, click anywhere on this line, anywhere, bring the cursor anywhere on this line and use Control Enter. That's a shortcut. So as soon as you run this, you see a replica here. This is your console. So you have your R's, you can write the code here and it runs in the console. Now there are times where you don't want to retain your code. You just want to use some code for testing, right? Let's say you want to look at what is there in Y. So Y has 1, 1.5, 2, 2.5 like that, right? This is a sequence. So if you just want to test it and not retain it, then you can use the console. Of course, both of these are running in the same session, same R session. So if you want to retain the code, write it here and you do a file save. You can do a file save here. You have a save as option, right? If you don't want to retain the code, you can just type in the console and look at the results. Okay. The top right one is where you have the environment. So you can look at which variables you have created, which tables you have created, right? What are the contents of these tables as well. So if, say for example, this is one table. This has 40 observations and 10 variables. You can click on it I'm not able to see. You can look at the contents here, but this is not the best way of looking at it. So if it is a data frame, you can also find it somewhere here. So I'll talk about that when we run the data sets. So for now, you can look at the contents at a high level. This will give you a summary of your data. All the variables which you create will be available in this window. Okay. And the last one, bottom right, you can look at the plots. So any plot which you generate will be available here. I can export the plot as well using the save as image or save as PDF. Okay. There are a lot of other options. As and when the requirement comes, I'll share those. So you should understand we have 4 windows. That is good for now. Okay. So our studio is a set of integrated tools designed to help you be more productive in R. It includes a console syntax highlighting editor that supports direct code execution, a variety of robust tools for plotting, viewing history, debugging, and managing your workspace. Okay. So the first and foremost thing which you should know here is your working directory. As soon as you open your RStudio, right, you should find out what is your working directory. So how do I find my working directory? I'll just use get wd. So this is a function in R which helps you locate your working directory. So get wd within brackets. So this is a inbuilt function. It's not a custom function. You have not written it. This is available in R. So this is what your working directory is. Now let's say you want to import all your files from this path. This is fine. But if you want some other path, right, from where you want to import your files, you can set your working directory. Set using set wd. Again, and you can just change your path. So for example, I want only D drive Intellipaat. So I'll just type in D drive Intellipaat and enter. Now to check that, I can use get working directory and see my working directory has changed now, right? I'll get back to the previous one. I'll roll it back for now. So we'll look at it when we start importing our files. So I reverted it to my previous working directory. So set wd and get wd. RStudio has accessible RStudio options are accessible from the options dialog, tool options. So we have general R options. So we're talking about tool, global options. Under tools, we have some global options. These are not mandatory, but it is good to have. You should know what all these are, what are the capabilities of RStudio. Okay. So general R options, default CRAN mirror, initial working directory, workspace and history behavior, source code editing, appearance and themes, pane layout. So these are more to do with your appearance and default settings. All you need to do is you open your R and start working. There is nothing, no customization required. If you want a black screen and a white text font, right, you can do that under tools, global options, but those are not like mandatory, right? Won't we use our GUI for programming? No, we are not going to use GUI. GUI is something which R does not offer. There are different startups which build GUIs on top of R. That is not free of cost. I'm not sure about R GUI, what exactly that is, but this is an industry-wide accepted format, and R Studio is widely used everywhere. R Studio, it's also very, very easy to install the packages. So what are packages in R? So as soon as you start working, right, you would need different packages to work. For example, dplyr. Dplyr is one package which you are going to learn in detail, which helps in data manipulation and data wrangling with a very, very easy to understand syntax. For example, you want to do a filtering of data, then summarize, then adding columns, doing a sum and group by, right? Then you can use dplyr. Now, all the packages will not be installed by default in R. What you have to do is you have to go to these packages. Okay, I'll first look at, yeah. So under tools, you can go to install packages. So it'll connect to the CRAN repository. CRAN is a global repository for R, which is maintained by certain group of individuals. Although it's an open source, there has to be some regulation, right? So CRAN repository is maintained by. So that is the website which I shared for the R installation. That is the CRAN website, and it maintains all the packages contributed by different programmers and institutions. So if you want to install the dplyr package, dplyr, you just type this and say install. I'm not doing it now, But if as soon as I do it, it will start running some command in the console and install it for you.
Just a quick info, guys. If you are interested in doing an end-to-end certification course in data science with R, then Intellipaat provides just the right course for you. You can find the course link in the description box below. Now let's continue with the session.
It will not take more than a minute, deep lab. But the other package, which is called ggplot2, which is used for data visualization, will take some time because it installs all those themes and other information. Okay. And when you do that, you'll observe that this is what is run in the console. Install.packages, and within bracket, we have dplyr. So something like this, it will run. And good, if they've started packaging it with a default installation, that is good news for us. But despite the fact that you have these default packages like dplyr and ggplot2, I would recommend you know how to install packages, because we would need to install a lot of new packages based on our requirement. For example, people who prefer SQL, right? So we have a SQL df package which can be used to write SQL like syntax in R. So all this data wrangling, right? You need not even learn R. I mean, at least need not be an expert in R syntax. You can just leverage SQL syntax to do the data wrangling in R. So that requires a custom installation of SQL package, which I'll show when we learn the classification algorithms. Then the next one is people who are comfortable and are used to pivot table, right, in Excel. So same drag and drop and pivoting like operations you can do in R using the package R pivot table. So that's why it is important to learn how to install the package. Okay. Other things are not very important. Git SVN publishing, please ignore for now. It is rarely used. Git and SVN, all of you know what is SVN is, right? Or Git. So these are like central repositories where you can maintain the versioning of your code. But yeah, you'll barely use it. Of course, there are ways to install packages from outside the CRAN as well, which is not recommended. Just like the Play Store or Apple Store, right? Especially Play Store. In Android devices, you can install different apps, right? But that's not recommended. That may not be secure, that may not be stable, right? So it's good to install from CRAN. And if required, you can also contribute, because in open source setup, right? You can also contribute free packages. Let's say there is a complex operation for which you need to write a lot of lines of code, multiple lines of codes. You can package it and release it in CRAN. So there's a different process which you can read about it. But if you're interested, you can do that, both in R and Python. So this we have seen our Studio GUI, script window, console window, environment window, and the plots. We have looked at R packages. Packages are, so formally, if you see, packages are collections of R functions, data and compiled code in a well-defined format. The directory where packages are stored is called the library. R comes with a standard set of packages. Others are available for download and installation. So Abdul is asking, can we use R for data science lifecycle? Definitely. That is why we are using R, right? So most of the things, complete lifecycle, yes, you can, because R helps in, will help you import data from different sources, right? You can do all kinds of data manipulation. You can do all kinds of, run all kinds of algorithms, model building, and then you can also do data visualization, right? So yes, you can use, but companies kind of use a combination of different tools. Sometimes they spend a lot of money on dedicated data visualization tools as well, right? But yes, you can use. So startups do sometimes rely only on R and Python, like either of these for the complete end-to-end setup. But then the problem is, like, when the data is at scale, you need some distributed systems, because R is an in-memory kind of setup, right? So what happens is, let's say you have 4 million customers. As soon as you do an import, this read.csv is doing an import. So all the 4 million records gets loaded in this memory that is in your RAM. So that's why you would rely on some other scaled systems like big data or others, right? R is not sufficient. Yeah, R on top of this Hive or cloud is useful. So I think the important ones will cover. So install.package is used for installing a package. You can also use the GUI for of RStudio. And if you want help for a package, you can use library help is equal to package name. Or alternatively, you can also go to this help window, this bottom right window, and click on the help and find a topic, anything. Say ggplot2. Do we have the help here? Oh, there's a search window. Sorry. Let me type in and check if we are able to search. Yeah. So if you type ggplot2, you get the full details about who is maintaining it and who are the contributors. You also get the GitHub link. You can look at the source code. That's the beauty. If you want to add more to it, say in ggplot2, there's one chart which is not available. One fancy chart you want, like chord diagram or donut chart or whatever, or some animations which is not available. You can always contribute. You can report bugs, and then you can read more about it. Devesh is asking, what is the data limit R can handle or manage easily? I would say not more than 300 MB, because 300 MB is data size. Suppose that you do a lot of data manipulation. When you do that, data gets replicated in your RAM. So more than 300 MB not recommended for data size. And the structured data will not be more than that, right, usually. And it also depends on your RAM. So if you are having a 64 GB laptop, RAM laptop, who knows, machine. People are buying all those GPU based machines today, right, these days. Then you can as well run like 4 GB of data in your RAM itself, local system itself. If the data is in huge volume, which tool is preferred instead of R? It's not about which tool is preferred over R. You do all the things in R and you leverage the distributed systems. It's an architecture layering. R sits on top of Spark or Hive or Amazon Web Services, right? Cloud services like Microsoft Azure, Google Cloud Platform. So R has to sit on top of it in order to handle so much data. You have installed R in your, I have installed R in my laptop now, right? I can also install R in these big data systems. R is not integrated with any DB. That is what Devesh is asking. Is R integrated with any DB? It's not integrated, but you can always have ODBC connections. There is no integration. R has its own format, proprietary format to store data in the memory, in the RAM, and that's how it does. Is it better to have the working directory as a cloud folder line, OneDrive folder? So Rohit is looking for a cloud folder. Yes, you can. If you have enough space in your OneDrive folder or any other cloud, you can do that. I'm not exactly sure. Yeah, you can do using OneDrive, because OneDrive, specifically, I know it maps to your local system, right? You can directly use a path if you have enough space. Yeah, Devesh, R stores its own data in its proprietary format in the RAM. What is ODBC? ODBC, but it's kind of a connector which connects to different databases. ODBC is a protocol or an API which helps in connecting to different databases. Like if R has to connect with Oracle or Teradata, the backend systems, right? It cannot be always flat files. Then ODBC is used. And all these setups will be done by the admin guys. You don't worry about the setups. As a data science enthusiast, data scientist, you should concentrate on how, once you get the data, what do you do about it? How do you get insights out of it? So all we are going to do is we are going to import data from CSV, which is the most commonly used data format in the industry. And most of the data scientists will get this CSV data for data exploration and model building. And once they are done with data model building, data engineers will help you scale your model in the systems, like connecting it to ODBC, JDBC, or to your big data, Hive databases, right? All these things will be done. Don't worry about that. Yeah, I think Sai has given the full form of ODBC. How do we decide if we have to go for R or Python? I think both are pretty much capable of doing everything, pretty much everything. Python is a general purpose programming language. I mean, I don't want to give a biased review, but Python has a wider coverage because you can do everything, right? If you want to design an API or do run some networking protocols or use it for data science, you can do everything in Python. You can do scripting as well, right? But the issue is, although Python is pretty famous, you would realize when you talk to full stack software engineers, Python is not very fast, and the learning curve is also slow because it is built on top of C and C++. Contrary to that, R is a very easy to use, and the syntax is pretty much simple. A simple copy of a table from other table, right, in Python is pretty complicated. You cannot just do a, say, table 1 is equal to table 2. Okay.
Just a quick info, guys. If you are interested in doing an end-to-end certification course in data science with R, then Intellipaat provides just the right course for you. You can find the course link in the description box below. Now let's continue with the session.
R is also built on C, C++. What I'm trying to highlight here is Python is marketed as a general purpose and very robust language. I do not completely agree with it. Although I use Python a lot, but what I'm trying to say is R is equally good. And sometimes Python makes it very much complicated when you want to do trivial stuffs like copying a table. So there is an indexing concept which was meant to make it faster, but it makes things very much complicated, right? So for any data science work, I think R is equally good. I would say R has to mature more on the deep learning stuff, the neural networks and the AI stuff. It's not very the open source contributors are not very active. Although I have seen like each and every algorithm which is available in R is in Python and vice versa till date. And there are few statistics functions, right, or statistical tests which are not very mature in Python. For example, I was looking for a mean Whitney U test and some other hypothesis testing which I could not find in Python. So it's difficult to decide between R and Python. I don't have a conclusion here. Both are equally good. It depends on the requirement. Yeah, one complaint I would not say complaint, but one observation which data engineers are sharing with me these days, like when we develop some algorithm and share with data engineers to scale it, right? We also, of course, sit with them and do that. But one observation is it's difficult to debug the R code when it is integrated with cloud systems. So the logs are not very elaborate to understand where the system has failed. While Python, because all this Spark and everything, right, all the systems have good compatibility, it's easier to debug. So that's one difference which I have heard lately. Okay. Okay, I think we can take up these kind of questions. I am fine with it. We'll slowly increase the pace. So Rohit is asking about how is data handled if data is in a language other than English. Okay, this is an interesting question. Thanks for this. So let's talk about some machine translation, this thing, right? Or let's say you want to do some recommendations and you have all the data in the form of text, let's say Chinese or Mandarin, right? And all that is in the text. And say there's a product which is written in Chinese and it has some characters. Say the product is bread, which is in Chinese. So number one, there are different APIs, language APIs, which understands its characters and provides an ASCII, assigns an ASCII, whatever, that number to it, and you can uniquely identify a character. If not, there are many interesting algorithms. For example, what2vec. What this essentially does is it kind of mines all your data, irrespective of whatever language it is, and based on the context window in which it appears, the co-occurrences of different words, it can identify what are the other words which are similar to bread, maybe synonymous to bread, just based on the concurrences. So that is the beauty of data science, where you can, irrespective of the language in which it is written, you can leverage the maths behind it. The one of the features is co-occurrence to understand the synonyms. Okay, and there are different APIs which does it. So for even for Mandarin, you have UTF-8, right? UTF-8, I think, is compatible with all the languages, most of the common languages. I hope that answers the question. Okay, so that's all about R. I think the basics of R. We will learn the functions in a bit. So installation wise, I hope you guys are able to install. Yeah, so we can move on to variables. So when we start learning R, we should understand what are variables in R. So variable is a temporary storage space where you can keep changing values. Like any other programming language, we have this concept of variables. And it is as easy as just typing in, say, x is equal to 2. And then you type in x, you get 2, right? And let's say you want to do some operation, like x is equal to 2 plus 3, and then say x. So x is 5. So do you observe something? This is the first time I'm using x, I never declared if it's an integer or whatever, float or character or whatever. So it's dynamic. Based on the data you store in it, it assigns a data type. Of course, every programming language will have a data type, otherwise it cannot work as expected. So here it is dynamic. Unlike okay, we can compare with C and C++. You have to say int of x first, right? And then you say x is equal to 2. So you have to declare the variable with the data type. So it is user friendly. Of course, there are a lot of operations which happens in the backend. As soon as you say x is equal to 2, in the backend it kind of reads the 2 as an integer and then assigns int as a property of this x variable, right? So yeah, it adds an override in the backend which has to do a lot of operations, but for the user it is user friendly. So data types in R. So data types are numeric, character, logical, and complex. So numeric, all of us know any number, like be it positive, negative, or even decimal, is numeric data type. And if you store x is equal to 5, it is an integer, x is equal to 5.5, it becomes a decimal. Okay. Then it's character. You also store x is equal to hello world. You can just try it out. I did not show everything. So here it is as simple as, like, say I want to convert x into a character, right? So I can directly write x is equal to hello world, right? Now this becomes a character. Let's say I want to check the type. So how do we do? I'm not sure about the command because, okay, this is class. So I also kind of confuse between R and Python, and that happens when you use these two languages interchangeably. So use class. Class of x gives you character, right? And if you now say x is equal to 2 once again, and then say class of x, it becomes numeric. Okay, so numeric, character, and then we have logical. Logical is true false. So it is more like 1 and 0. So if you run an if else condition, you do any test, right? You get true and false as two outputs. So based on this, you can design your code and develop some logic. We'll look at it when we run some functions like checking if a string is contained within a string or if a character is present in a string. We'll see. And the last one is complex. Rarely used, but all of you know what is a complex number, right? It will have a real and an imaginary component to it. So like 30 minus 2i. So 30 is the real component, 2i is the imaginary component. You can think of it like x and y axis, the two coordinates, 30 comma 2. I'm not sure how to use it. Let's see, because I have never used complex numbers. Let's say x is equal to 30, but you guys can let me know if there's a use case for it. We can try that out. Yeah, so now x is equal to 30 minus 2, right? And if I say type of x, you can think of a use case for it. I'm sorry, class of x. So it is a complex. Okay. Okay, I'll take a few questions. Is there an order in which we take self-paced courses? I would say this is the order because what I do is start teaching data science from the basics as far as to the best of my knowledge. So I think this is perfect to start with because data science doesn't have much of a prerequisite. We leverage the elementary mathematics and knowledge about simple mean, median, mode, all those things, right? Which you have used in your high skill mathematics. We just leverage that those knowledge. There are not much prerequisites. So you can start with this, and on top of this, you can start building up your knowledge on if you want to learn big data and other stuffs like data visualization, right? But I think this is where you should start with. The way she's suggesting Excel, yeah, Excel, yeah, again, it's a platform. But what I was trying to highlight was you should know what is mean. You know what is average, right? Mean. Then why do we really need median? What's the need for even having a term or a concept called median? So I'm talking about the basic stats. That is where we should start with. Do we need to brush up elementary maths? If so, from where can we do it? Nikhil is asking. Okay, don't worry about brushing it up now. If required, during the sessions you realize that something is going on top of it, like over your head and talking really at a very high level, then do that. Although I make sure what we learn is like from the very basics and any 8th or 10th grade student can understand. We are not going to do any rocket science here, just the basic data and try to learn the art of how to leverage that data. and how to treat the data. Very basics. So don't worry much about mathematics. The mathematics, what is required, I am going to discuss in little detail. Okay, Sai, you can declare both single quotes and double quotes. Abdul, we are going to discuss the theory and implement the R side by side. So the R file which you see on the screen, the three R files, that is what we're going to discuss as part of introduction to R. And then we'll move on to a little bit of data visualization. So we'll just work on a data set. We'll have like rows and columns in a structure, and we'll try to do some summarization like sum and group by and mean, all those things. Okay, so first we'll learn some data wrangling. Okay, and then we'll learn some data stats, and we'll come back to R to implement those stats. So don't worry, I'll follow the sequence. Which is more complex, R or Python? Python is more complex. So we can get started with the other concepts and syntax and semantics with R, where we'll be covering most of the R syntaxes. We'll not talk much about core data science or any data handling activities. We'll not cover anything of those, but that's fine. I mean, this is pretty important to start with. This will help you get started with or onboard you know how you can leverage R for any of the basic statistical functions. Okay, so the first one is data exploration, where we'll cover objects in R, meaning any programming language will have some objects, right? It could be in the form of placeholders where you can store your data, right? So these are all derived from the traditional programming languages. Most of the objects are similar. So we'll go through objects, then flow control statements. Flow control is more about something like if, else, case, when, or maybe for loops, while loops, right? Although you would not need the loops a lot for the statistical analysis, but it's a good to have thing, right? If you want to automate your reports, automate your data science work, this helps you, do that. Then we'll cover a few inbuilt functions and move on to also defining how we can define our user-defined functions, right? Post that, we'll cover data manipulation, and if time permits, we'll also jump onto data visualization. So that's the agenda for today. So objects in R, you see this tree diagram. I think it's a pretty exhaustive one, which helps you understand all the objects. So broadly, it's classified into one-dimensional and multi-dimensional. What is one-dimensional? Say if you just want to store, say, color of all the apparels in your database, right? So it's like one column, right? So one-dimensional. And then we can have multi-dimensional, right? We want color and size and something else. So think of when you want to try to relate it to the data. So one-dimensional, multi-dimensional. Under one-dimensional, we have homogeneous and heterogeneous. And same for the multi-dimensional, we have homogeneous and heterogeneous. So homogeneous, we'll explain what is homogeneous in it. First, we'll try to understand. So under homogeneous, we have vector. So it's an open source world. There are times when few functions may not work in the latest version and may work in the older version, and vice versa. So what generally companies do, they kind of stick to one version of R, which is like latest but may not be very latest, could be like 1 or 2 months old, for which everything is tried and tested and all the packages are stable. So you need not worry about that, but that is what happens in the industry. So maybe you have installed 3.6.1, you stick to that for at least 6 months for now, unless and until you observe a major release or something. Okay. So homogeneous and heterogeneous. Homogeneous, the example is vector, and heterogeneous, the example is list. And under multidimensional, we have matrix as homogeneous and data frame as heterogeneous. So what are these? Vectors. Vector is a linear object which contains homogeneous elements. So it is a collection of values that all have the same data type. So number one, it's a linear object. And second, it contains all the values of the same data type. So if you look at it, C1, 2, 3. So all the contents are integers. The second one, C true, false. All the contents are logical, either true or false, right? You cannot mix one and true and false like that. Okay? So this is how it is. Okay, I'll just go through the chat window. So the easiest way to check if R is working, once you open R, you'll get a similar console. Try for something like x is equal to 2, okay? And then type in x, you should get 2. If R is working, RStudio is not working, you might consider installing RStudio once again. but based on what error you're getting or what is the issue you're facing, you can write to support. The presentation is available for everyone. You can just log into your Intellipaat portal and download from there, I believe. We have just started, Krishna. Nothing has been missed. Okay, Abdul is asking what do you mean by linear object? Okay, so when I say linear object, as I said, it is one dimensional. We don't have two dimensions to it. No rows, no columns. It's like just one row or one column. That's it. You can think about a flat file. So going back to the presentation, yeah. So when I say linear object, that means either one row or one column. So you can think of a data set, a regular data set in any of the ERPs or backend systems, right? How does it look like? It has rows and columns, right? So you have a customer table. So customer will have each row represents one customer, and each column will be the customer attributes. So customer ID, the identifier, then customer age, customer income, and so on and so forth, right? So when we say linear object, you can think of just one column, say customer age, and that is what vector can represent. It cannot mix anything. It's just one single column and with only one data type. That's why we're calling it homogeneous. So C1 to 3, C true false, or maybe in terms of age, C 20, 30, 40. Okay. Look, so most of the operations and most of the data analysis, what you're gonna do will be on something called data frame. You're not going to use vectors for any analysis, right? But it is good to know all the data objects which are available in R, right? But most of the things what you will be doing is on top of a data frame. Okay, Sai is asking if only one row is present, then can we say it as data set has only one row or one column? If one row is present, it is one row. Okay, so there is no confusion. If only one row is present, it's called one row. Any example where we can use vector? Okay, not really now. So what I'll do is we are only introducing these terms, right? So vectors definitely can be leveraged when you want to automate. So I'll give you a scenario. I'll not show the solution for now. So scenario is if you want to automate, let's say you want to impute the missing values. You have 1,000 columns in a data set, in a data frame, and you want to impute and fill all the missing values with some random number, say 0 or something for now. Although there are definite strategies to fill how to impute the missing values, but if you want to do that, you can leverage the vectors. Okay, fine. So creating a vector, it's pretty simple. C is this function. So if you want to create a numeric vector, you just say C and then 1, comma 2, comma 3, comma 4, comma 5. This means every element separated by a comma is one element. Prakash, impute means replacing any value with something. So let's say you have a lot of missing values, nulls or NAs, and if you would like to replace all the nulls with a 0, right? Then that is called imputing. More on that later. That's a separate topic. So that's where you can apply the vector. So creating a vector is, as I said, it's pretty simple. You can just use the function C, and within brackets, you can pass on the elements in a comma separated format, right? So this is one way of doing it, and the basic way of doing it. The second way is, say if you want a sequence, you can just do num2 C of 10 to 20. So what this will do is it will create a sequence from the range of sequence from 10 to 20, 10, 11, 12, and so on till 20. Okay, if you want to go with the character vector, so remember it's homogeneous, right? You cannot have character and number in the same vector. So if it's a character vector, all the elements have to be character. So the format remains same, C of, let's say, A, B, C. So as it is a character, it is important to enclose it with a double quotes. Okay, so you can also extend this to words, not only letters. So anything enclosed within a double quotes, right? Anything includes within a double quotes is a character. It could be one letter or combination of letters, right? Like a string. So second vector is cat2 assign C within brackets. This is Sparta. So this is the first element, is the second element, and Sparta is the third element, right? So C, guys, C here stands for create. If you read the documentation, C stands for create. Okay, and the arrow which you see here, it's an arrow which is like an assignment operator. It's just like equal to. So you can either use equal sign or an arrow pointing towards the vector name. So cat2 is the vector name, right? So this arrow is pointing towards vector name. So let's quickly create these two vectors if I have this similar examples. So you can look at it, vector 1, arrow, C1, 2, 3, 4, 5, 6, right? You can either run it here or just copy this command, copy this function and run it here in your console. So what this will do, this will create a vector with the elements 1, 2, 3, 4, 1, 2, 3, 5, and 6. And how do you check it? So yesterday, if you remember, we learned this class, right? Class vec1. So what happens here is when you're working in R and say you have a complex code of 1,000 lines of code, right? And you want to edit or do some enhancements. It's not like you'll always get a fresh code, right? So this is how you debug and check each and every object in R. You use the class command. Now here it says numeric. As soon as it says numeric, you should understand it's a numeric vector. Okay. You will look at other data objects, how what it denotes. So for list, it will give you a list. For matrix, it will give you matrix. For data frame, it will give you data frame. So we'll check that in some time. So we can also run the. So I'm running this line now. Num1 C 10 to 20. So this is giving me what? Num1. What is num1 now? You can check here. So 10, 11, 12, 13, 14, 15 till 20. So what I'm doing here is, if you can observe, the code snippet which I want to retain are written in this file. And if I want to do just some debugging and all, right, I don't want a num1 to be written here like this. I just want to check what num1 contains, right? So I need not, I can omit it from here and directly type in here to check. So this code will give you the same output, just like what I have done for the second line. But the only difference is this code will not be retained. It's only for your debugging. Okay. Num1 is not an array, guys. Num1 is still a vector. And the equal to sign and the arrow sign can be used interchangeably. This is interchangeable to the best of my knowledge. Okay. So the only advantage of an arrow sign is if you use a vector, say this is my definition of vector, right? I can just type in the vector first, like whatever you want in the vector, and then you can also change the arrow direction and say this is my num1. So this just gives you the comfort of where to place the definition of the vector and where to give the contents on the left or right. That's it. If you're getting some errors, I'm not sure what error you're getting. Unexpected comma between values. You just need to copy this, but you should have the text with you. Just be careful, how many commas you have and how many elements you have. But guys, I recommend please do not practice while we do this class, okay? I really don't recommend that. The reason is, you waste a lot of time. These are pretty simple functions. Don't feel insecure. You can always practice it anytime. It is a very, very simple file. So don't feel insecure of the syntax. Syntax is pretty easy. R is a very easy to use language. You can see these are like so simple functions. Just one time run and you'll remember. Okay. So did we create character vector? We don't have. Okay, that's fine. I need not create and demo everything. So this is character vector. Okay. Next one is creating a logical vector. So it is very similar. You just need to say C of true, false, true, false, whatever you want. So true represents 1, false represents 0. And these are keywords. Okay. These are keywords. You cannot say TRU or something. It has to be TRUE completely. And TF is also, it also represents true false. It is a short form of true. Okay. So one thing we can check quickly is, are we able to create these vectors? So I have one vector which says true false. Oh, I'm sorry, I just messed it up. Okay. So vector 2 has true and false, two elements. Now you can ask me, where can you use this true and false? So this is where you can leverage this for any kind of automations. Say you are attempting a very complex programming challenge where you have to automate all your data manipulation. This true false will really help. You want to store, say, do you have, is it a null or not, right? For all the records, then you can store it in the form of vector and then pass it on to some other system. These are the scenarios, but you cannot define a specific scenario in. Like, once you understand what kind of task you have in analytics, it will be easier for me to explain where you can use a vector. to automate your data science stuff, data wrangling stuff. Okay. Now, if you want to impute your data, right? Impute, all of you know, impute means replacing an element, right? So let's say if your vector has some null values, and null in R, null means nothing. Okay, in any database we have something called null. So null represents nothing, a missing value or a blank. So null in R is represented by NA, this NA. So let's say we have a vector which we create and we deliberately have few NAs. Now if you look at it, vector 2 has NA1, 2, NA3, 5, NA. It has like how many? 3 plus 3, 7 elements, right? And we have 3 missing values. How do you check? So it's a very long vector, it's a huge vector, right? So we can just say is.na. It returns a logical vector, true, false, false, right? So true means yes, the value is na. False means the value is not na, right? So this function is.na will stay with you for a long time because this is helpful in imputing missing values, which is one of the most important data science activities. So we'll spend some time here on this topic. Okay. Now let's say if you want to impute and replace all these NAs with 0. So just use a simple if else statement. If else is a function. It's again a inbuilt function. If else, and within brackets we have 3 parameters here. Okay, 1, 2, and 3. So first one is the condition is.na. First one is the condition. The second one is what do you want to impute it with. If this condition satisfied, then what do you want to impute it with, and if it does not, what do you want. That's the way you write a if else statement. So let me run this and let us check the vector now. So 0, 1, 2, 0, 3, 5, 0. All the NAs are imputed by 0. Abdul, the arrows are just for the direction. So if you write the definition first, then you use the second option which you have given, and if you have the vector name first, then you give the first one. It just gives a direction of what to process first and assign to what. So the parsing part will be first, right? And then assign to some variable. So either way is same. So this was a basic data object in R. Moving on. Okay, so you can also find out the length. So if you just say length of the vector name, we'll get the number of elements in the vector. Okay, so few functions you can try yourself. They're pretty straightforward. Accessing the elements of a vector. So how do you access? If you just want one of these, right? You can just say vector name and within bracket which element you're going to access. 1, 2, 3. So let's say we have, I think I have it somewhere else. Let me just find out. Accessing the elements. I don't type anything for now. Yeah, I'll create few vectors. Okay, so length of num1, we have num1 is having 5 elements, right? So we have 5. Then length of char1 has 3 elements. So it gives us 3, right? Then if you want to access the second element of char2, where is char2? This is char2, right? And we want the second element. So all you have to do is just say char2, and password 2. So this will give you is the second element, right? If you want the first element, you just say char2, 1. This will give you this, right? Additionally, you can also go with, so if you want more than one element to be printed, right, or returned. So for example, for my log2, you want the first and the third element. So what do we do? Basically, it expects a vector of 1 and 3. So this is like we want first and third elements. So true and true, first and third. It starts with the 1 here. You can observe here, right? When we are saying character 2 of 1, it gives me this. Okay, I think we have seen this. Imputing missing value. Next one is list. List is a linear object which contains heterogeneous elements. A list allows you to gather a variety of objects under the name. A list may contain a combination of vectors, matrices, data frames, and even other lists. Oh, so pretty powerful. So what it's trying to say, it's again a linear object. It's like, although I would say it's not strictly linear, we'll see that how, but it is like one single list. As the name suggests, it's a linear object. It has one single list, and it can contain heterogeneous elements as well. And the syntax is you just say list within brackets, say an integer, a number, one not one, and then a string, Sparta. Now these are two different data types, but can be fit into one single list. This can be packaged or zipped into one single list, right? So that's the advantage of having a list. You can have multiple data types in one single object. Now what does the last sentence mean? It may contain a combination of vectors, matrices, data frames, and even other lists. So this means within a list you can have, let's say, just one number, one string, and you can also have another list, matrices, data frame. So say first element could be just one vector, vector of length 1. Second element could be a vector of length 1. Third element could be a whole data frame, meaning 1000 rows and 10 columns. Or the fourth element could be a matrix. So that's the beauty of list. Now, how you apply it depending on the requirement. So to be frank, I have not used such a complex list till now because most of the operations are on data frame. You can think of some way how you can leverage the most complex form of the list. So creating a list using the list function, you just say list within the brackets, you pass on the elements. Okay. So you can observe here, the first list has all the elements of same length, 1, A and true. Although these are different data types, first one is numeric, second one is character, third one is logical, but all are of same length. Same for the list 2. We have list C of 1, 2, C of AB, and C of true false, all of same length, that is two elements, right, in every element of the list. How do you access? So you just say within double brackets, you give the element number, which element you want to access. So say second element, I just say my list 1 within double brackets 2. Okay. What happens in a list is because we have multi levels here, right? Within an element, I can have multiple elements. So I might want to access an element within an element of a list. So for that, we have this double bracket paradigm. So say I want the second element of the third element in the list. So I say my list 2 and then within double brackets 3 and then within single brackets 2. So this will give me false. So 3 and the second element is false, right? This will give me false. Okay, let us execute these. Let me see if I have these handy. Yeah. So my list 1, you can always print it for your reference. 1A and true, and then my list 2. So in my list 2, I have tweaked the length. The third element has three sub elements, right? So you can also do that. It need not be always of the same length. First element has two elements, second element has two elements, third one has three. Okay. And you'll observe I'm using the C syntax within a list. So within a list, we can have a vector, right? These are all vectors. These are all vectors. So if we want the second element of list 1, what is the second element of list 1? Just to make it more interactive. My list 1, what is the second element? 2. Second element is 2, is it? It's A, right? Second element is A. So if we do this my list 1 of 2, then 2 of my list 1, this will be A. Okay, let's tweak it a little bit. So I'll say 2, oh, I'm sorry, 2 and 1. So what am I doing here? What will it give? My list 2 of 2, 1. What is the expected output? If you guys follow me quickly. My list 2, I'm accessing the list my list 2 and 2, 2, 1. I passed within double brackets 2 and within single brackets 1. Okay, let's see. Perfect. So this is what we expected, right? Now I'll go back and so we can also name the elements of a list. So what happens in a complex scenario is when you want to create, want to make it more user friendly, right? To access the list, you can just give a label to every element. So the syntax almost remains the same. We can say list and say first element is 85, second is 45, third is 100. But you want to specifically provide a label, you can say apple is equal to 85. Most likely it is like the price of apple per kg and then price of banana per kg and price of guava per kg, right? So labeling the individual elements of the list, this is how you do it. List of label equal to the element, label equal to element, label equal to element, like that. So what this does is it makes it easier to access the list elements. You can just say the list name and then dollar the element label and it returns 85, right? So I create this list and I can access 85. If I want to access banana, right? Banana label, just do this and replace apple with banana. The output should be 45, right? Okay, just scrolling through the chat window to check if there are some queries. So Nanda is asking, is object always associated with storage only? So it's about storage. Yeah, it's about storage and how you store it. Yeah, I'm not sure what else the application could be. This is about how you store it, and then while data wrangling, how you can leverage it. Right. So yes, Nanda, we can define an element with just data within an object. We can do that. A linear is like one row of data. It's one dimensional. Okay, if I happen to miss some question in the chat window, you can just copy paste and put it once again. Yeah, dollar is used to get the value when you have a labeled list, only in the case of labeled list. Nanda, the name of elements has to be unique. That is true. So if you want to use the names within the beyond the list, right, you have to use the dollar paradigm, a list name dollar banana. This way, it is very difficult to relate this to the real-time data sets. The only object which is closer to real-time data sets is a data frame, and that is what you're gonna work most of the times. But it's my job to explain all of the data types, right, before jumping onto data frame. Okay. Yeah, Kriti. So C of 1, 2 is given so that we can return multiple elements in one go. So if I just say my log of 1, it will give me first element. My log of 2 will give me second element. But if I want both first and second, I have to pass C of 1, 2. And C means create a vector. So it is a vector of all the indices within a list. Anand, yes, there are always guidelines for naming the variables. You need to follow proper guidelines based on the domain in which you are working. These are just toy examples, but when we work with real-time data, you'll see how the variables look like. Akhilesh, can you try the duplicate one at your end and let me know? I just need to quickly cover other things. So you can try and let me know if you get some error. If you don't get, we learn something new. Okay, fine. Remember, like these are all, I would say, just the introduction to all these objects. Most of the times, or I would say 99% of the times, you'll be working with a data frame. So that is why we'll spend a lot of time on the data frame. Okay. So like there are a lot of objects which are seldom used. You also have matrix for that matter. And the next one is matrix. I don't remember I have used it any time in the past till now. Unless and until you go for some recommender systems where you only have one single data type, that is number, right? When you convert everything to a vector. For example, in Netflix you have like thousands of movies, right? So every movie has to be represented in the form of vector, in the form of numbers. So there maybe matrix will be useful, but even that can be done using a data frame. So data frame is a one-stop shop for you. All the data manipulations can be done using a data frame. But let's see what is a matrix. Matrix is a 2D object which contains homogeneous elements. Again, two-dimensional, meaning rows and columns. If you see the output here, we have rows and columns. We have 2 rows and 4 columns. Okay. And the way you create it, so the easiest way to do it is matrix C1 to 8. So we give a sequence. Let's say I want 1 to 8 as my elements, 1, 2, 3, 4, 5, 6, 7, 8. And we want it in the form of 2 rows. So it automatically splits your data into 2 rows. Okay. So creating a matrix, the syntax is just say matrix. So for creating a vector, you had C, right? You just use C. That represents creating a vector. How do you create a list? You just pass on list, L-I-S-T list. Within the brackets, you pass on the elements. How do you create a matrix? You just say matrix, M-A-T-R-A-X, matrix. And within the brackets, we want the elements. But because matrix is a two-dimensional object, we need to be careful with how do you want your elements to be. So the first parameter is you have to say what elements you want in your matrix. So let's say I want 1, 2, 3, 4, which is a vector. All these elements I want in a matrix. Wherever you see, you observe this C, right? This character C. This means it is creating a vector. So a vector of these elements are there. 1, 2, 3, 4. I want this in my matrix. And how do I want it? I want 2 rows. So 2 rows. So automatically, if you have 4 elements and 2 rows, you'll have 2 columns, right? So we'll have 1, 2, 3, and 4. And the third one is by row is equal to true. That means start assigning the elements to the different placeholders and fill the row first. So 1, 2, and then 3 and 4. Okay. Then a slight variation. You can say C, A, B, C, D. Again, we have 4 elements. N row equal to 2. Okay, here we don't have any variation. It's only filling the characters instead of numbers. So you can do that. If you do by row equal to false, okay, if you do by row equal to false, so what this will do is it will first fill the first column A, B, and then C and D. That's the only difference. And you can also do it for the logical elements TF, TF, and you get the same output. Now, how do we access the matrix? So you need to use basically you need to you have to pass on two things here, right? One is row number and the column number. So if you say mat1 of 2 1, 2 represents the row number and 1 represents the column number. So the first one is the row number, second is the column number. Now what happens if you just say mat1 1 comma nothing? That means first row and all the columns. And if you say mat1 nothing comma 1, right, or space comma 1, so that means all the rows and first column. So this is like coordinates, x and y coordinates. So you access different elements using these two parameters, row number and column number. So matrix name within square brackets, row number, column number. Okay, if you remember the transpose, so if you want to exchange the rows and columns in a matrix, so you can use the transpose function. Okay, so mat1 is 1, 2, 3, and 4. So let's say you want to do a transpose. So you just say T of mat1. So what this will represent is, see, 1 and 4 will remain same because this was 1, 1 and 2, 2. So it cannot exchange the rows and column number, right? But the other two elements, 3 and 2, right? 3 was 2 comma 1 and 2 was 1 comma 2. So it just exchanges. So all the elements except the diagonal elements will get exchanged. Yeah, Vivek, you can create a matrix with numbers, but not a combination of number and complex numbers. So if I go back to the slide, if you remember, matrix is homogeneous. So whenever we have homogeneous, right, only one data type is allowed. So that's where you can use a data frame, which is more realistic. Okay, I'm just going through. Okay, did not get by row. Okay, we'll see that now. So let me open up and create this matrix. So this is my mat1. What did we pass? We passed four elements, 1, 2, 3, 4. We passed this to the matrix function and we said we want two rows. And we also said by row equal to true. So what this did? It filled the elements 1, 2, 3, 4. So it is filling it by row. Row first row, fill everything, then go to the second row. Let me try by row equal to false. So it did work. And what is happening now? We are not filling it by row now. We are filling it by column. First fill, so it's in a sequence. How to fill these elements in a sequence? So fill the first column, 1, 2, then go to the next column, 3 and 4. Yeah, I think by default by row is 2. Okay, did I miss any question? Yeah, Manish is asking, you did not use C in the fruit list. Yeah, the fruit list is the labeled list, right? There, C is not required because for every element we have a label. So that's a completely different syntax. Don't worry, you need not remember so many syntaxes, guys. Data science is not about remembering syntaxes. Don't worry about the coding. What you guys can do is you can just leverage this PDF or this R file, right, as a, I would say, just a reference, ready reference for syntaxes if you don't prefer doing Googling, right? So that's all you should use it for. Don't try to remember it by heart. I mean, nobody expects. And even if you go for interviews, right, in a 1 hour interview, hardly 5-10 minutes will be a coding one. They just want to know if you know R and leverage all these things. That's it. Nobody's expecting you to do a lot of coding. When data frame is available, why would one need matrix? So I can give you an example. Matrix is faster when you have homogeneous elements and when we want to do something like cosine similarity. That's what you might not know what is cosine similarity. If you know, well and good. So things like vector two matrices multiplication, right? It is easier when you have the matrix object instead of data frame. Data frame is assumed to be much more complicated in terms of how it stores data in the backend, right? Because it has to be in the form of rows and columns, with every column being heterogeneous, right? It's not similar. One column would be a number, other column would be a date type format, right? So what I'm trying to say, metrics will be useful when you want to do a lot of mathematical operations on bigger matrices. Remember the 10th grade or 12th grade mathematics, where you would do matrix multiplications. So it is difficult to explain you now. Once you understand how a recommended system works and how these cosine similarities are used, then I can give you an example of how matrix is leveraged. And my second answer is to this question. I mean, this programming language is evolved, right? It has to have all the objects, and then it goes to data frame. Data frame is the most immature object. So initially, these all things came. These may not be used. All of these may not be used, but these are there in the programming language. I personally, data frame is enough for most of the operations, and that is why, as a programmer, if you have something in the armory, you have to check how you can really leverage them. So one thing I remember is matrix gives you better performance when you have homogeneous kind of scenario. You have to multiply two matrix. And by cosine similarity, I can give you a little bit detail. So what happens is again the Netflix example, every movie can be represented in the form of matrix. When I say matrix will be in the form of say every movie has a feature, right? Movie could be from a genre, movie has a length, like how long is the movie has some actors, director, or whatever, right? So all these features within a movie could be within a sum of numbers, and that will nothing but a matrix. Now if you want to understand the similarity in two movies, that is nothing but finding the similarity between two metrics. So if you go by the geometry and the calculus which you have learned in the high school, you can multiply these two matrices and find out one single number which will give you the angle between these two. So it might go over your head for now, but bear with me. I'm giving you a high level example. So that angle will tell you how different are these two movies based on all the features which you have embedded in the matrix. And in these cases, matrix might be a little faster compared to just multiplying two data frames. Okay. And by the way, we are yet to do data frame. I used no need to remember all the syntaxes. Not at all. Okay, Sai is asking if placing by row equal to false, it already looks like a transpose matrix. Why do we need a transpose? Okay, once we already fill a matrix with say 1,000 rows and 1,000 columns, we cannot refill the matrix, right? So it's only while filling the matrix first time, and post that if you want to transpose it, that's where transpose is used. And by the way, transpose has a lot of other applications. It's not only just here. So you might need transpose to find out the matrix inverses. So if you go with the linear algebra concepts, say you want to find out, say matrix A multiplied by X gives me matrix B. So if you want to find out matrix X, that's where you would need a lot of transpose operations. So more on that later. If you want to go deep, you can start learning linear algebra concepts and linear programming concepts on top of matrices. So transpose is a useful function for that. Okay. So did we create matrix 1? Yeah, matrix 1 is created. We also created matrix 2, which is all characters. So we created it now A, B, C, and D. Then matrix 3, all of these are logical elements. True, false, true, false. You can print it. Okay, I typed in the wrong place. Mat 2, then mat 3. All these you can print. Then you can access the elements. If you want the first row all columns, you can say mat 1 of 1 comma everything. You get 1 and 3. Then all the rows first column, then you get 1 and 2. Then second row and first column, you can just say 2, 1. And then if you do a transpose, it gives us 1, 2, 3, and 4, which is the diagonal elements will remain same, 1 and 4, only the non-diagonal elements will change. And if you want to find out the average of say all the rows, only second column, right? So what do we have in the second column? Let's see in the mat 1, what do we have in the second column? Second column is 3 and 4, right? So what this function is saying, mean of mat 1 comma 2. So what is there in mat 1 comma 2? We have 3 and 4, right? All the rows, only second column. And what would be the mean? Mean would be just the average of 3 and 4, which is 3.5. 3 plus 4 is 7, and 7 where 2 is 3.5, right? Same thing you can do for mean, mat 1, 2, comma this, which is 3. Okay, so you'll observe here that the original matrix and the transpose matrix is just like reversing the coordinates, row and column. That's it. Okay. For the non-square matrix, I think I just executed it here. So what I meant by saying non-square matrix is the rows and columns are the row length and column length are not equal. We have two rows and three columns here, right? And on top of that, if you do a transpose T of mat, so what it does is it just exchanges the coordinates. So for example, for the element 1, what was the row number and column number? It was 1 1, right? So if you just change it, it will again be 1 1. How about 3? 3 was 1 comma 2. So it will become 2 comma 1. See here, 2 comma 1, right? How about 5? 5 is 1 comma 3 in the original matrix. Now if you just interchange, it will be 3 comma 1, right? 3 comma 1. Similarly for all other rows. This is what we meant by the non-square matrix. Although in the linear programming paradigm, you'll have a lot of theory around this concept and how to find out transpose, inverse, and eigenvalues. I'm not going into details now, but those are also good to have skills in the long run. I'm not asking you to learn now, but yeah, revisit those concepts. I'll talk about that when we learn few algorithms and the next steps, what you can follow after this course. How to view the top left window, Abdul? Okay, so you can go to the file menu here and just say new R script file, new R script, and start typing there. You can also use the plus icon, which you have it here, the plus icon, and say R script. By the way, RStudio has also started supporting Python and other like C++ and other files, but we will restrict ourselves to R for now. Okay, I'll move on to data frames instead of learning the arrays for now. Next one is data frame, and then I'll talk about arrays. So let us first look at data frames. Yeah. So what is a data frame? I'm skipping the arrays concept. Again, not very important. I first want to cover data frames. So a data frame is a 2D table. Again, it's only two-dimensional, remember. So how about matrix? What was the dimension for matrix? 1D, 2D, 3D? That's 2D, right? Rows and columns. Similarly, a data frame is also a 2D table where each column comprises homogeneous elements and each row contains either homogeneous or heterogeneous elements. Meaning, it is just a spreadsheet data what you see in real life, right? So the basic syntax of creating a data frame is data dot frame, and then you say the first column name. Name is equal to C of Sam and Bob. So this is what you'll have in the name column. And then comma age is equal to C of 3248. So this will give you this result. Name is the column name, age is the column name. Sam and Bob 3248 are the two elements. So one element from name column and one element from age column. This makes one row. Sam 32 is one row. Bob 48 is another row. Okay. Now, how do you access the columns? Let's say you have a data frame with like these 7 different columns, and you want to access one column, the data for one column. You can just say data frame name dollar column name. Just like the labeled the labeled list, right? We use dollar. So here column names act like labels. So let's check if we can create a data frame now. Yeah. So we have this data frame, Sam and Bob. We create this, and if you want to access, so I've not assigned it, right? So let's say I'll say test df. I'm giving it a name is equal to data.frame. So this is my test df. I can print it completely here. Name age Sam Bob 30 to 48, right? So to access a column name, test df dollar. I have two options. Let's say I go for name. It gives me Bob and Sam, or I can go for age. Can we create a cube? Devesh is asking. Cube means three-dimensional. Yeah. So create a cube-like structure. You can use arrays, which we have not covered now. So not only cube, you can have 3, 4, like 1,000 multi-level, multi-dimensional objects. Now, where would you need that? I mean, good. We will. So what I do is I'll create a requirement for these things. Where would you need a cubical structure? Although it's not very common, but yeah, we'll talk about that. That's interesting. You can use it using arrays. Okay. Now, for data frames, generally you'll not create all the data here, right? You'll not do it inline because data frames could be huge. You could have millions of rows. So one way to do it is we import it from an external say CSV file or other data files. Do you guys know what is a CSV file? Ayush, I'm coming to that. Customer churn. What is a CSV file? Do you guys know that? Yes, Anand, we can extract row wise. We'll see that now. So what is a CSV file? Yeah, so it's a comma separate file and each column is separated by a comma. So I have a file in the backend. I'm just passing this. I'm giving the path and the file name, and then I'm using read.csv function. This is the most common file format used in the data world. If you're not using a database, CSV is the way to go. And the reason is it consumes very less space. So I imported my file and I want to check what is there in this file. So let me see if this command works. View of customer churn, although it will be huge. It's not recommended to view the full data set. I'm taking that risk now. So in RStudio, if you use this command view of customer churn, you'll get this kind of structured data format. And this is what we have imported. We have customer ID, gender, is the customer a senior citizen, 0 or 1. Likewise, a lot of variables. Is the customer it's a telecom data set. Is the customer a partner? Yes or no? Does the customer have any dependents? What's the tenure of customer, age of customer in the system? And then what all services he or she has subscribed to: phone service, multiple lines, internet service, online security, and so on. So we have a lot of columns, and then in the end we have a label: churn, no churn. Churn means the customer left and switched the network, and I mean no means the guy is still with the system. Yes means the customer has left the system. Okay, so this is how our data frame looks like. Now I'm just wondering, actually, once you import the data, and you can click on this and view the data set, but somehow it's okay, it's happening. So instead of using the view command, you can also click on this customer underscore churn. So this gives you a better view of the data. You cannot do this in the R. You cannot do this in basic R. You have to go with the command. The GUI interface for looking at this data in such a structured format is not available. That's why we leverage RStudio. Okay, Anand is asking, does this reading file not require any modular package? No, this is by default there. But there are a lot of customized packages which can help you read data in a very short time frame. So it will help you enhance the performance. So those customizations are available. You can browse if you wish to. But read.cs is the most common way of importing a file. If I only want to look at gender, I can just say customer $gender, and this gives me the gender of all the customers. And that is not the best way, right, to view the data. Not the best way. It's good to go to this view window and look at the gender for every customer, because you want three-dimensional view. I mean, you want the 360-degree view, right? You want to look at all the other columns and then the gender, right, in a spreadsheet format. Okay, how to access a column using the column number? Because it's not always easy to access the columns with column names. Let's say you want to plan an automation. You want to access the third column. So you can also do that using customer. You just give the data frame name and within the brackets something comma 3. So blank comma 3. Blank means all the rows and the third column, just like matrix. All the rows and third column. This is what you get. So this is the default R output, and this is what you get as an add-on in RStudio. So on the console, what you get is the way R works, and this is how RStudio will give you in a more structured way. So it's a little easy to understand, right? And if you want, let's say 3 columns, you can just say customer churn, all the rows, comma C136. It will give you first, third, and sixth column of this data set. So if you see, we have first, third, and sixth column. I cannot scroll up. It has a lot of records. Now, how do we see the number of records? If you want to look at number of records, there's the first thing you would like to do, right? As soon as you import data. So what do? N row of the data frame name. So this will give you, so we have 7043 rows, 7043. Okay. And dim command, we can use dim, and this will give you the number of rows and columns as well. So it has 7043 rows and 21 columns. Okay. Now lot of other things. You can do something called STR. STR stands for structure of this data frame. So what is structure command? Structure is telling you, okay, it gives a summary. We have 7043 observations, 21 variables. We have all these variables, and for every variable, we have the data type, int, factor, int, factor. What is a factor? We'll discuss. And then for every variable, we have the sample records. Like for gender, we have male, female. For senior citizen, we have zeros and one. Like, but it will not give you all the records. It is just a summary, high-level overview of what your data set looks like. Okay. So let us go a little away from this syntax. You might be a little bored, right? What is a factor? And I think we did not cover it yet till now, right? We know a number, integer, then character, and then a logical this thing. Data type. What is a factor and what is the need? We'll not cover it completely, but let us understand what is the need. So all the categorical variables, right? We have discussed, right? A machine only understand numbers. So all the categorical variables like category is equal to gender is equal to male and female, right? Here, how will the machine understand male and female? So you can just say, okay, why not give it some labels like male is one and female is two, right? So what happens is when you pass this to the system, to the machines, when you're learning, when you're applying all these algorithms, right? In the backend, internally, it will try to kind of assume, say, male is one and female is two. That means females are by default better than males, right? Or vice versa. It could also say one like males are better than females, or females are, I mean, both ways. But that's not true. But that's what we didn't intend to. If we intend to do that, we can pass on one and two labels. So that is why here we don't want to create any biasness. We just want to say, okay, these are two categories. We don't know which is good or bad or who is performing better or worse. Maybe based on some other variables, like if you're analyzing the marks or average marks of students, right, for the male and female students, then maybe it will decide based on some other column. But just by looking at this column or gender, we don't want the machine to decide anything, right? So for that reason, this factor data type was introduced, which basically means these are two categories and there is no difference between these two. These are just two categories. And in the backend, how it is done is within the R system, it basically follows the one hot encoding paradigm. So for all the categorical variables. So let's say I give gender, right? And I have like male, female, female, then male, then female. I have like 5 records. So what this will do is it will create two variables, gender underscore male and gender underscore female, and it will pass on the numbers. So if it's a male, male is 1, this is 0. If it's a female, this is 0, this is 1. This is 0, this is 1. This is 1, this is 0. And this is 0, this is 1. Likewise for all the records. So these two columns will be passed to the machine or the R software or any other algorithm which you are working on. Okay. So these two will be passed on to the machine. Now we can extend this to the other, like if we have more categories. So instead of gender, we have some other, even gender, we have 3 categories, right? Which is socially acceptable, right? So if you have 3 categories, then we'll have the third category here. And then based on that 101, this is called one hot encoding. This is also known as one hot encoding or dummy variable creation for categorical variables. So what happens in R, you need not explicitly create this. As soon as you declare a variable as a factor, that means internally it is creating these variables. Okay, so I'll quickly address Nanda's question. Instead of always importing data into an object, can R read and process data in the table directly? Okay, so R doesn't have that functionality of doing the operation directly on a table. It is an in-memory programming language. It always imports and does the operation. If you want to do that, there are Hive systems, right? You can call Hive parallel processing systems directly from R, which will pass on all the functions from R and use it as a pipe and do the operation in the table and come back. So that facility is there. It's called piping. So if you are, let's say, familiar with only R syntax, or let's say only Python syntax, so that piping can be done. Write the syntax in R or Python and then call it from a Hive system, which will do all the manipulations and pass it to the system directly there. But R implicitly doesn't have these things by default. How and where can we admin R to ensure enough RAM and processing is allocated to R to function? Okay, good question. So if you would have observed while installing RStudio, you would have got something called RStudio Server. So this is a client-server architecture. In an ideal scenario, R is installed in your local desktops and laptops in your machines. But when you work on the projects and when you are uploading your code, right, project codes, the codes are always in a server, and that server has the R installed for you, and it follows a client-server architecture. So we have one centralized server, which is like 80 GB or 100 GB RAMs. Can just give an example. And all of the R clients, right? Like you as a user will use one R client, other developer will use another R client, and they'll connect to this server to access the RAM. So that's where that management happens. And RStudio server is the place where you can do all these kinds of management. So don't worry about that. You are not going to work on any admin stuff. The admins will be able to easily handle it. Can we get all command shortcuts in one document for a future reference and application? That's why you have got the deck, Suresh. You can refer the deck. And if required, I can share some cheat sheets link. Those are readily available in the internet. You can download some cheat sheets. Like the deep layer package, which we are going to learn in detail, you'll have a one-page cheat sheet for deep layer. And that is, I think, all what you would need for any kind of data writing activities. So we are going to learn data deep layer shortly. Any data frame size limitation in R? Sumitra is asking, I mean how big data? Okay, that depends. So data frame size also depends on how many columns you have, right? So there is no official limitation, but it depends on your RAM, as I said, what RAM you have and how much data you should process. How we imported the data frame. We use the read.csv command. We passed on the path of the CSV file, and then we just use this arrow to indicate that all the data should be loaded in this customer churn data set. This is the data frame name. So if you do a type, the class of customer churn. So remember I told you, every time when you create one object, it's a good practice to look at the class. So it says data.frame. Now it's not a list, not a vector, not a matrix, right? It's a data frame. So this is how you create a data frame. Our script storage is very less. It's in KBs. Manish. Yeah, Anand, we are acting as clients when we follow that client server architecture. Yes, Abdul, CSV file is a data set, and most of the times in the projects, so what data engineers or other source application teams will do. So, for example, you got a requirement where you want to mine how people are behaving in the app. Where are they clicking? Where are they hovering over? They might be going to the pay option and then stopping there, right? Due to several reasons. It could be a bad UI or something else. So all this customer journey in the app or website is captured in tools like Clickstream and Click. I think there are a few tools. So if I want to work on these systems, right? Basically, what you do is you get access to the systems and then start working on it. So they will kind of export and give the share the data set in the form of CSV to do all the POCs. Once you're done with that, you'll have a data engineering and software engineering team who can help you plug and play this algorithm or the statistical model into their systems. Okay, did I miss anything? Okay, so as I said, what is a cube? We have a two-dimensional data set, right? Rows and columns. But what is a cube? I'll take the text data. So as I said, any text data like a movie name, how will you represent a movie? So first you'll have like 1 million movies, and for every movie you'll have certain characteristics like length of the movie, the actor who acted in the movie, or what is the genre of the movie, right? And who is the producer or whatever. A lot of things, right? So now these are just two-dimensional things, movie name and then different factors. Now how does it become three-dimensional? If all of these factors I convert into an array, like just the movie genre can be an array. How array? Array is two-dimensional, right? Or matrix is two-dimensional. So movie genre can be split into like what is the genre type, and then within the genre, what is the sub-genre, right? And then within the genre, is it a mix of multiple genres? So it's like every single word can be represented in the form of one matrix or array. So that's where it becomes three-dimensional. After this data set, if you go one level more, that becomes a three-dimensional, which will, I mean, you will realize in some time after 1 or 2 weeks, right? once we discuss few data sets, you'll realize how that happens. And what is the need of creating a three-dimensional data set, especially in the case of text mining and recommender systems, we would need more than two-dimensional because every data point is further split into vectors. So whenever you want to compare two words, right, we need to know what other hidden features we have in the word. Like an apple and mango can be compared and say, okay, these are very similar because both are fruits. But what about the context? Is apple used in the context of a tech company, or is it a fruit? If that was the case, in when the context is something different, then apple and orange are not very similar, right? So that's why these are the hidden features. So every word is also split into a matrix in the backend. So further creating another dimension to this data, that is where we need three-dimensional, four-dimensional, and so on. I hope you got an intuition. More on that later, I would say. Ayush, just follow the file. What is the error for CSV you're getting, Ayush? You said you're getting some error. Okay, make sure the path is correct and the slash. You have to use a slash. I don't know what it is, back or forward. How do you call it? But this is what you have to use. And by default, if it is in Windows, the slash will be different. It will be the other way around. So either you can do this or double of this. So by default, if the slash is like this, then you have to use two slashes in Windows. So this will also work. So just make sure you follow this syntax properly. Read.csv. Why are you using CAV? I'm not sure why CAV. It should be read.csv, not CAV. Okay, fine. We'll go through some other things in data frame. Okay. So when you have the data set, you can also look at, say, once you start exploring, right? What did we see? We looked at number of rows, dimension, then the structure, right? Then other way to look at data set is if it is huge. So as soon as you import, you should not say view, because it will give you the whole data set and your system might get stuck or hang, right? So better go for head. It will give you top 6 records by default. If you want to customize, you can say head data frame comma 10. It will give you top 10 records. Head data frame comma 2, top 2 records, right? Same for tail. Tail will give you bottom 6 records. So let's say if you don't have RStudio, this is how you start looking at data. Even in case of RStudio, I mean, this thing might get stuck if you use this right all the time. It's a huge amount of data. It's like a replica. Already this much data is there in your RAM, and then when you click, it kind of displays it here, right? So this this interface will also consume a lot of space if you have so much data here. Then you can do tail, comma 3, comma 10, right? End row and column we have checked. Another important one which I think I missed out is you can look at summary. So you can just say summary of the data frame. Very useful because initially, when you do the data exploration, you have like billions of records. These things are very handy. In one single shot, you're able to see so many things. So what is summary giving us? Summary will give you, as the name suggests, a summary of what the dataset is all about. It is basically giving you the summary statistics. Let's talk about a column. I'll choose one column, tenure. So under tenure, it'll give you what is the minimum tenure in a dataset, what is the maximum, what is the first quartile, median, third quartile, and mean. So don't worry about quartile. We'll learn quartile when we start statistics. But this is giving you an overview of what your data is and what is the range, minimum value, maximum value, average value, median, first quartile, third quartile. Like in one single shot, you get this view of this variable, and not only this variable, all other variables. And the difference is for the numerical variables, you get all this statistics in the form of min, max, mean, median, all those things. For categorical variables like gender, because mean doesn't make any sense, right? A minimum maximum doesn't make any sense. So it'll give you the count of each category. Like we have 3,488 females and 3,555 males in our data set. Okay. So these functions, yeah, you should remember or at least keep it handy somewhere. Summary, str, head, tail, end row, dim. These things you should remember. Okay. Explicitly, if you want to calculate the min, max, and max, all these things, right? So if you see, if you pass on these to a vector, say max of C 1, 2, 3, 4, 5, you get 5. So if you do max of one column, customer churn, dollar, monthly charges, that will give you the max of that column. So that, what does that mean? Can you observe an analogy here? So every column in a data frame is nothing but a vector, right? So data frame is a combination of multiple vectors, right? So max of customer churn dollar monthly charges it is giving us. So we have a customer who has spent like $118.75 pounds, I'm not sure, but that is the maximum monthly charges in our data set. The shortcut to run these codes, I said yesterday, right? So just bring the cursor here anywhere on the line and say control enter, and it will automatically detect if it's a multi-line code. It will completely run that statement. Rely on the dplyr package. It has an arrange. The command itself says arrange, I think. So we'll look at that. Merging, again, we'll look at dplyr package. Merging and joining. Left, right, and full outer inner. For minimum, you can just say min. Min of customer churn monthly charges. 18.25 is my minimum monthly charges. Mean is the average. All of you know what is an average, right? I will not explain. But I'll cover this mean, max, and median in little more detail, how you can apply average in different scenarios. And why do we really have something called median? If average does everything, why do we have median? So range is the min and max, max minus min. So difference, so basically it's giving you min and max both. Then there's something called sample. Instead of doing a head and tell, you can also do a random sampling. It may not sound very interesting or important now, but we'll see how sampling will be relevant when you do the statistical modeling. So let's say if you want to get five customer IDs at random, right? You can just say sample customer churn dollar customer ID, comma 5. It'll give you 5 random records, 5 random customer IDs. Can we do it on the whole data frame? We can do. So either you do on a column or on the whole, on all the columns. So sampling will be very, very important in the subsequent sessions. We'll see how it is important. Okay. Anand, it is a line by line code execution. It is a line by line code execution. Okay. So there's another function called table. Table is a handy function to summarize data. Say if I am saying table customer and dollar gender. So this is giving me a summary of how many records we have in female and male. So I mean, similar stats we're going to get using different functions. There are a lot of repetitions I know, but you should know all these functions. Okay, these are row bind and column bind, R bind and C bind. So a lot of times you might have to, someone call out merge, right? So this is the initial, the start of understanding how do you merge two data frames or maybe add one column to data frame, right? So R bind and C bind are handy there. So what is R bind? R bind stands for row bind, and row bind means if you already have a data frame, how do you add a row to it? Or if you have two data frames, how do you just vertically stack two data frames? So let's create one data frame called student. Let's create one data frame called student. How is the student looking like? Again, Sam Bob and 725. These are the name and marks. How did we create? We just use the inline argument. Data.frame, name equal to C, Sam Bob, marks equal to C, 97, 25. Okay, fine. Now I am converting my name to character. I can use as dot character. I'm sorry, I'm still reading the, we can convert this into a character and we can use as dot character for the same. Fine. And now I want to add a row or add one more student, Anna, and the marks is 75. So all I can do is R bind. All I have to do is R bind data frame 1 and the second record. Sorry, the new record. Right. So if I do this, I get Sam, Bob, and Anna. Right. So instead of this just one record, you could also add one complete data frame like student 1 and student 2 complete. So this data frame 2 might have more than one record. It's like vertically stacking two data frames. So you can use rbind. And so we'll look at the bigger example where we stack two data frames. And if similarly we have one student data frame and I want to add one more column, that is grade. So in that case, it is horizontally stacking, right? So this was my data, name and marks, and I want to add one more column grade. I can say R bind data frame 1 and the column. vertically and horizontally stacking. Ayush, if we change the original data in spreadsheet and save it, does it get updated? No, you have to always import. It's in memory. As.character only converts the data type from it ensures that name is a character. Why do I use it? So let me create this student and look at the data types str and see what is happening. So name is becoming a factor, although we didn't want name as a factor because see, you don't want to measure someone with the name, right? Yeah, if someone is a male and female, you can differentiate. So categorical variables have two types, factor and character. So I want it to be by default character. More on that later. We'll discuss in detail. As I already explained, right, what is the relevance of factor, but we don't want name as a factor here. So we just convert it into character. Okay.
Just a quick info, guys. If you are interested in doing an end-to-end certification course in data science with R, then Intellipaat provides just the right course for you. You can find the course link in the description box below. So this brings us to the end of this video. If you have any queries, please do comment below. We would love to help you. And also do subscribe to our channel so that you don't miss out on our upcoming videos.